with us and imagine what's waiting to be learned. Before continuing, please pause this instructional video now and collect your study book. And now, Can You Imagine with Mansfield Thornbottom. On today's episode of Can You Imagine, we'll investigate the properties of wind. Have you ever felt wind? If you have, then you probably know it often has immense force. Nobody knows what wind truly is. We know that it's caused by a number of conditions, including birds, wind farms, and shifts in atmosphere as both hot and cold air collide. But what is wind? It's difficult to define because, like germs and ghosts, it's invisible. Experiment 1. An experiment was carried out to ascertain whether or not it's possible to contain wind. Our scientist holds the balloon between his two fingers and blows, filling the receptacle with a kind of false wind. Can you see it expand? As the balloon reaches its critical expansion point, the scientist releases the balloon's open end and demonstrates that the wind, while contained, has never ceased to circulate within the confines of the rubber orb. The scientist then blows it up a second time and ties it off at the base. We know that water can be both a solid and a gas, and almonds can be whole or crushed. But can wind ever be anything other than wind? The answer might surprise you. In fact, with enough heat, nearly anything will melt. This rubber balloon, however, is impervious to high temperatures as it is comprised of special elastic, created by the National Aeronautics and Space Administration. The rubber is heat resistant, but the air inside of the balloon will melt upon exceeding 900 degrees Fahrenheit, thus converting itself into a new viscous material. Our scientist places the balloon gently into a microwave oven and presses the 30-second button, and then steps back, waiting patiently for the transformation to take effect. Do you know what state the air will take upon being heated to this immense temperature? Tell the classmate next to you, or write it down in your study book. Upon opening the microwave, it doesn't appear as if anything has changed. The balloon is just as round and solid as ever. But we know that this visual state can be misleading, as can be extrapolated upon further analysis. The balloon's structure has withstood the heat, and now the scientist picks up the orb. It is warm. Write that down. Immediately, we find that the air within the balloon has drawn in moisture and various vitamins from the atmosphere around it. The scientist carefully penetrates the balloon with a sharp object. It pops, and we instantly find that the air inside of it has congealed and mutated under the intense heat. It now resembles a bizarre goopy slime. This wind slime, as it is called, is found naturally on the planet Mercury, our distant neighbor closest to the sun. Yes, as wind snakes around the alien landscape in midday, the sun's rays cook the noxious air, thus spilling congealed ooze across Mercury's cavernous plain. But wind slime emits a deadly vapor, and should not be kept in a confined or windowless room. Children of all ages may enjoy this byproduct immensely, provided simple precautions are taken. Begin by placing the ooze in a bowl and instructing the children to take it outside. When they're done and all the ooze is spent, simply dump it in a moving river and discard the bowl immediately afterward. Experiment 2. An experiment was carried out to discover if wind can occur naturally within a home, given the proper combination of both hot and cold air, or if it is strictly a product of our natural environment. The question was proposed during a bizarre occurrence in Oxnard, California, when in 1967, wind seemed to occur entirely out of nothing, thus knocking over chairs, slamming doors, and even causing furniture to move abruptly. This experiment is begun by taking a hairdryer and turning it to the on position. Be sure that there are no open windows that might interfere with our results, and please be aware of water. If the electric current running through the hairdryer were to make contact with a water source, the results could be hazardous, even deadly. Next, we open a freezer door and blow the hot air directly into the open compartment. Almost instantly, we can see a massive increase in the air's movement, ever more so than would have been present given the freezer's natural status. This is a hopeful sign. We'll continue blowing the hot air into the open freezer until enough wind has culminated within the house so as to be self-sustaining. And after a few moments more to this experiment's success, we find a small cyclone has taken shape and is now ripping its way through the kitchen. Already, this experiment has proven fruitful, but it's given further credence when the couch suddenly shifts backward and a closet door is wrenched open. Now we've done it. This windstorm is slowly getting out of hand, and the experiment may no longer be safe. But fear not, for all that's required is the simple act of opening both the front door and a rear window. This will create a wind tunnel and should cause the storm to subside almost immediately. But oh my, it seems as if the window won't open. Next, the scientist grips his head in agony as whispers flood his mind and he screams at the sight of a young child. But an experiment is only failed when no results are documented. And so, in conclusion, we can end this experiment by acknowledging that yes, wind may be produced indoors. However, the results can often be haphazard, and any one outcome should not be solely relied upon. We hope that you have enjoyed this episode of Can You Imagine? And we hope you'll take special care whether you're playing with wind slime or summoning a miniature cyclone. You can never be too careful in your experiments. And as always, remember to keep imagining. You may now close your study book and return it to the professor at the front of the classroom.